Okay, in the last video, we were using the quotient property where we were given a single radical and we broke it up into a numerator and a denominator. Now we're going to be going backwards. In this problem, we have a square root of 8 over square root of 2. Now, we can't take the square root of 8 nicely. I mean, it's not a perfect square, and neither is 2. But do you notice that 8 is divisible by 2? So maybe if we were to rewrite this as a single root, 8 over 2, now we can do some simplifying. Because 8 divided by 2 would be 4. So now this is the same thing as the square root of 4, which we know to be 2. That's how that simplifies. Let's work a couple more examples using that. Okay, here we have one that's the square root of 48a cubed over the square root of 6a. Well, looking at these, again, these are some pretty messy roots. Neither one of them are perfect squares. But do you look at this and notice that 48 is divisible by 6? So if we were to rewrite this as 48a cubed over 6a, we could do some simplifying. Now that means that 48 divided by 6 would be 8. And a cubed over a, remember your exponent rules. Your exponent rules say if you're dividing like bases, you subtract the exponents. So 3 minus 1 would be 2. Now we always have to check and see if we can simplify further. So looking at the square root of 8, it's not perfect, but it has a perfect square inside of it. Because 4 times 2 is 8, and then we're going to bring out our a squared also. Now we can take the root of each one of those. So the square root of 4 is 2. We know that. We can't do anything with the square root of 2, so we just leave it alone. And we can take the square root of a squared, as 2 goes into 2 one whole time. So that would be an a. And we would have to just leave the square root of 2 since we can't break that down any further. So that would be our simplified answer. Okay, one more, looking kind of nasty here. Again, we've got cubes on top and bottom, but neither one of these are going to be pretty to deal with. And here we have an a to the negative 1 on bottom. That negative exponent means it's not in the right position, so we really need to bring it up. But we can't do that unless we write it all as the same radical. So this would be the cube root of 104 a to the 5th over 4. Now I can bring that a up on top and put it as it is because we're writing it all together as the same radical. And then we can simplify. So that would be the cube root of 104 divided by 4 would be 26. And a to the 5th times a, when you multiply like bases, you add the exponents. So that would be a to the 6th. Now, we need to see if we can simplify any further. 26 is not a perfect cube. And in fact, our perfect cubes would be 1 cubed is 1. That doesn't help us. 2 cubed is 8. Well, 8 doesn't go into 26, so we can't break it down using an 8. 3 cubed is 27, and that's too big. So that this will not break down any further at all. But the a to the 6th will, because 3 goes into 6 2 even times. So that would be a squared, and then we would still have underneath the cube root the 26. So simplified, that looks like a squared times the cube root of 26.